So what I'm going to do this week is I'm going to walk you guys through, this is going to be your first final exam review. So let me pull the whiteboard up and just kind of show you. So it looks like I've already sort of deleted this one, so that's good. Basically, your due date coming up on Wednesday. You're going to take your electricity magnetism test. You're going to have nothing going on next week. Okay, next week is Thanksgiving. We don't have anything the entire week. Okay, this is a great time to spend time with your family, or if you're so inclined, you can start, doing your test corrections if you haven't done them, or doing the synchronous session ELOs, both of those, which will help you prepare for the final exam, which is very, very soon after we get back from Thanksgiving. I know it feels like December is really far away, but it's not. Okay. When we get back from Thanksgiving, that Wednesday, you're going to have no test due. You've got a couple assignments, but no test. That Friday, okay, so Wednesday you have a due date and Friday that week. That Friday is December 1st. Your nuclear physics test is due that day. If you don't turn it in by Friday, it will be late, okay? So you have to turn it in on Friday. Then December 5th, which is Tuesday, is the very last day to turn in any makeup work, that nuclear physics test. If you missed it, you have to turn it in by the 5th. It's, even if you get an extension or whatever, everything is due the 5th. All the Dropbox folders will close, all the tests will close, everything will close, and you'll be done. Okay. You will not be able to turn in anything after the 5th. Okay, that is virtual school policy. That is not my personal policy. Okay, do not email me on the 6th and say, can I please turn in my test corrections today? I will say no. You've had all semester to do it. Okay, so if you want to get any of those extra points for like the ELOs, for example, like watching this review or test corrections or anything like that, you have to do that by the 5th. The 5th is a Tuesday. We'll also have a session that night. Okay, that'll be a last final exam review. Okay, we have to wait till then. One, because we have to have a session on the 5th, but two, I can't look at your nuclear physics test and see what you missed until you take it. And since you have to take it by Friday, then by that next Tuesday, I can have the questions that were most often missed. December 6th and 7th, that's a Wednesday and a Thursday. That's your final exam. You have to take it. It's 90 minutes. It's 20% of your entire grade. It's basically the same as every single lab we've done this semester. So it's really important that you take it, okay, and that you try and do well on it. On Friday, December 8th, your course will close. It'll be done. And then on the 9th, I'm allowed to start grading your exams. And you guys should get your grades by like the next Thursday or so. So that's kind of how the end of the semester works. I have written in here, final exam review dates. Today we're going to do 1D motion, 2D motion, and Newton's laws. I'm talking really fast because there's a lot of questions to go through today. The week after Thanksgiving, I'll review application of Newton's laws, energy, momentum, and the first half of waves. And then December 5th, I'll do the second half of waves, electromagnetic radiation, electricity, and nuclear physics. Okay, for the ELO for each of these, there will be a question from each one of these units that I will do tonight in the session. And then you just go to the Dropbox folder, you look at that, you work out that question just like I'm going to do. And then you upload your work and the question and your answer, obviously. Excuse me. And then I'll give you a point on your 1D motion test if you do the 1D motion one. I'll give you a point on your 2D motion test if you do the 2D motion one. And I'll give you a point on Newton's laws test if you do the Newton's laws one. There's one for each one. Okay. So that adds about like 2.5% to your test. So that's, it's something. So it's worth doing, I think. But, I'm kind of biased given that I'm the teacher. So here's what we've got for this review. What I did is I went through each one of these tests that I'm going to talk about today, and I looked at the question statistics, and I picked the questions that were the most missed, that had the least % correct, basically. And I'm going to work out those. If you want me to teach you those concepts that are in those questions, go back to the synchronous session for that unit, and that's where I actually teach the concepts. In this section, I'm just going to try and work them out for you, and I'm going to try and go pretty fast because I want to get as many questions as possible answered for you, okay? I'm only looking at the multiple choice questions because your final exam is all multiple choice. There's no free response. So I didn't want to waste time on free response if that question can't show up on your final exam. Okay, so each one of these questions I go over, it's a possibility that you might see that question on your final exam. Okay, so just keep that in mind. Now, at the beginning, I'm going to show some formulas. These are formulas that you should have on your formula sheet. If you don't have a formula sheet yet, or you haven't made one this semester, go ahead, get a blank piece of paper, pause, get a blank piece of paper, and write these formulas as we go on, okay? These are the formulas that you will need on your test, okay? So that's kind of what I've done there, is I've made sure that way you can cross-check with your formula sheet, or you can make a whole new formula sheet if you want, that you've got the formulas that you need, okay? Now, so let's try and start working some of these out. Okay, so for this type of problem, I really like to draw a number line, okay? So if I could get a flat one, which it probably won't, I'm not very good at drawing a flat line. I kind of draw something like this, and then this would be like my 0, and then I'm like 5, 10, and every time I try and work one of these problems out and I don't draw a number line, I make a mistake. I was actually talking with another physics teacher, and we were going through some of these problems, and she said the same thing. She's like, yeah, if I don't use the number line, I'll try and go fast. I get them wrong. So, it's not just a student thing, it's a teacher thing too. It just makes it easier to kind of see what's going on. Okay, so I draw the number line. Now, technically, it just wants the displacement from point B to point F. So we could just draw point B on here, and we could draw point F. But I'm going to go ahead and draw all of them on here because, there's other problems like this in the test. So point A is 0, and point A to B is 15. Okay. Then let me get another color. Hopefully I don't run out of colors. And from point B to C, C is negative 30. So we're going to go all the way from 15 to negative 30 to get to C. Then from C to D, D is 20. So I'm going to go back the way I came. Okay, point E is, what does it say, negative 10. So that's right here. So again, I'm going to have to go back the way I came. And then point F, let's see, another color. Kind of running out of colors. Point F is 5. And I'm just going to put F here because from E to F, I'm kind of running out of space. Okay, so from what I need is I need from B to F. So to get to B, from B to F, I'm going to have to go backwards 5, 10. Okay, so I'm going to have to go 10, negative 10. Okay, that's my displacement, is negative 10, or you could say 10 meters to the left. Either of those would be an appropriate answer. So it just depends on what they have as a choice on that multiple choice question. Now this one, in this equation, the x is going to be This is the change in distance, so it's going to be here we go. Okay, so we would have, so this is basically your change in distance. So it'd be like your first distance minus, or your final distance minus your initial distance, and that would give you, okay, whatever your answer is. Okay, so which of the following of these is a velocity? So first of all, we know that velocity has units of meters per second. Okay, so anything that doesn't have units of meters per second is not a velocity. Okay, this guy, not a velocity. Since that guy's not a velocity, this is automatically not a choice. Okay, then we know that velocity is a vector, which means it needs to have a direction. Okay, so it needs to be either north, south, east, west. We can write left or right. Both of those would be possible, or we can write positive or negative. Okay, so this is the only one that has a negative and a meters per second. So this is the only one that is a velocity. So that's going to be your answer. Okay, so here's another one. We have a boy, he's walking north at 11.2 meters per second for 14.7 seconds. So this is going to be my velocity. This is my time, and then it says how far does he get? That's my distance. Okay, so I'm going to have v equals 11.2 meters per second. My time is 14.7 seconds. My distance is, I don't know. Okay, so I'm going to do v equals d over t. I'm going to put that in the triangle. D goes on the top, t goes on the bottom, v goes on the left. I'm looking for d. So my d is v times t. So I'm going to have 11.2 times 14.7, and I'm going to get 164.64 meters north. Okay, the question may or may not have north on there, but you know he's going north because that's, you know, the direction he's walking. Next. Okay, so if velocity and acceleration have opposite signs, we need to choose one. What's going to happen? Okay, if your velocity is positive and your acceleration is negative, the object speeds up. Speeding up is a acceleration thing, and in order for an object to speed up, your acceleration must be positive. So that is impossible. Okay, if velocity and acceleration have opposite signs, then the object will slow down. Well, not necessarily, right? It could speed up, it could slow down. It just depends, right? We don't know. Okay, so this is not a good one. This one says if the velocity is negative and the acceleration is positive, the object speeds up. Remember what we said with part A, or choice A. If the acceleration is positive, it's going to speed up. Okay, your velocity is negative, that's fine. That just means you're going to speed up going backwards, if that makes sense. So you're like accelerating in reverse. Okay, and then D says the object will speed up. Well, not necessarily. It could slow down, right? So that's not a good choice either. So C would be our choice. Now, when you're taking the final exam, this is kind of a little tip I learned when I was in college. Since your test is on the computer, but sometimes they give you multiple choice, what I like to do is I like to have like a piece of scrap paper with me, and then I'll write like A, B, C, D on it. And then like for this one, I'll cross off A, I'll cross off B, okay, C is my answer. Okay, and it just kind of helps me keep track of the different choices and you know, my answer. So, you know, you can try it. Couldn't hurt. So now we have a ball is being thrown downward with an initial velocity of 12 meters per second, or 12.1, excuse me. So that's going to be my VI. how long will it take to reach a velocity of negative 24.5 meters per second, VF, and then negative indicates the downward direction. So here's the issue here that I think a lot of people have. Here, it said it's thrown downward, so they didn't put a negative here, so a lot of people didn't put a negative. But it says that negative is the downward direction, so that means this would be a negative velocity. And then your final velocity is negative 24.5 meters per second. We also know our acceleration, which is g, okay? And that's going to be negative 9.8 meters per second squared. That's probably something that you should have memorized, okay? And then I'm going to look back at my formulas on my formula sheet, and I'm going to look and see which one makes sense, okay? I want to find a time, how long, okay? So I'm looking for time. So I need to find a formula that has an initial and a final velocity and a time. And I don't want height, I don't want distance, I don't want any of those other things because I don't know those and I'll have too many things that I don't know. Okay? So when I look at the formulas, I find this one. And my G is my A. Okay, so I'm going to have negative 24.5 equals negative 12.1 plus negative 9.8 T. Okay, first thing I want to do is the things that aren't attached to my T, I want to put those together. Okay, so this is going to give me a negative 12.4. Then I have negative 9.8 T. I'm going to divide both sides by negative 9.8. You see that my negatives cross out? That's good, okay, because there's no such thing as a negative time. So since my negatives are crossing out, that tells me that I'm doing something right. Okay, and I'm going to get 1.27 seconds for my time. Okay. See, I told you I'm going fast through these because there's a lot of them, and I want to make sure that I can work through as many questions as possible for you guys before we run out of time. Okay, so a ball is thrown upward this time with an initial velocity of 12.1 meters per second. And then how long will it take to reach a velocity of negative 24.5 meters per second? Okay, so in this one, since our ball is being thrown upward, at first, that initial velocity is positive, and then our final velocity is still negative. So basically, our ball is thrown up, and then it's going to be coming back down. Okay, our acceleration, or g, negative 9.8, that's always in the downward direction. And then how long? So we're looking for a time. Again, we want a formula that has a final and an initial velocity, and we want it to have time in there somewhere, but we don't want distance or anything like that because we don't know distance and we'll have too many things we don't know. Okay, so we're going to use that same formula we used before. Okay, and this is just going to kind of show you, you know, what it looks like if you're starting going up or you're starting going down. Okay, I'm going to take this negative 12.1 and I'm going to put it on the other side. That way the two things that don't have T's on them can be together. So now we're going to have negative 36.6 equals negative 9.8 T. I'm going to divide both sides by 9.8, negative 9.8. You can see that my negative is going to cross out again. That's good. Remember, we can't have a negative time, so that wouldn't make sense. Okay, so this is 3.73 seconds, and that's because we're going to go up and then we're going to come back down. That's going to take longer than being, you know, the last problem we were being thrown down and we were already going down. Okay, so that's going to take a little longer. So that's why it's, you know, more time. Okay, so the slope of an acceleration versus time graph. So acceleration is meters per second squared, and time is in seconds. So if you have meters per second squared, y, right, because we've got like y over x, right? Your slope is always your rise over your run, which is your y over your x. Okay, so then we'd have meters per second squared per second, which isn't anything. Okay, so the slope of an acceleration graph is nothing. Okay, it's not like a velocity time graph is acceleration, a position time graph is velocity. An acceleration versus time graph, the slope of it isn't anything. Okay, so now we have a graph, and we want to use this graph to determine the change in velocity between 0 and 4 seconds. Okay, so let me show you where that is. That's this part of the graph right here. Okay. Now, to determine the change in velocity in this section, what we can do is we can get the area under the curve. Okay, so this is a triangle. This part is 4, and this part, you see, because it goes to 4, and this part is -4. Okay, and so the the area of a triangle is 1/2 base times height. So I'm going to do 1/2 times 4 times -4. So I'm going to have, it's going to give me -8 meters per second. Okay, so that's how you determine, not on an acceleration time graph, how you determine the change of velocity. Okay, if you had a different type of graph, it wouldn't be the area under the curve, but for a acceleration time graph, it is. Okay. Okay, now we're at 2D motion. Okay, these are the formulas that you'll need for the 2D motion unit. Um, excuse me. Again, write these down on your formula sheet. Make sure you've got them because you will need them. Okay, I didn't, come out of them out of thin air, right? I used them to solve the problems in the next few slides. Okay, so make sure you have these on your formula sheet, or if you're making a new formula sheet, you write these on your new formula sheet. Okay, so now we want to do the correct equation for the y component of a vector named A with an angle measured from the x-axis. Okay, so for the y component, you're going to have A cosine theta, and for the x, it would be A sine theta. Okay, so A tan is nothing, and A divided by cosine is nothing. Okay, so if they ask for the y component, it'll be that one. If they ask for the x component, it'll be that one. Okay, so what is the direction of a vector with an x component of -12 and a y component of -15? I'm going to pick a different color. I don't like red. It's stressful. So the first thing I like to do is I like to draw a coordinate plane. Okay. And then I'm going to actually pick some more colors because I want you to be able to see what I'm doing. So my x component is negative. So that's going to be in this direction. And it's going to be -12. I don't have to label it or anything because I'm just going to do like that. This is just going to give me kind of a frame of reference, I guess. Okay, and then my y is -15, so it's going to be down this direction. Okay, and then I'm going to find, I guess yellow. I'm going to find this yellow one. Okay, that's my vector. This is the thing I want. Okay. So what I want is we want the direction, right? So we want this angle right here. Okay, so what I'm going to do is I'm going to do, our formula is tan to -1 y over x. Okay, so if I do tan -1, my y is -15, My x is negative 12. I'm going to get 51.34. Now let's look at this. 51.34. Does that look like it's going to be 51.34? No. Okay. So what I need to do is I need to add 180 degrees to that because that's basically giving me this, and I need to get this other part. Okay. And that's going to give me 231 degrees. Okay. If they wanted me to find the length of this section, then I could do a squared plus b squared equals c squared and solve for c. Okay. Now, here we go. Here's a projectile problem. Okay. So we have a projectile that is launched horizontally from a cliff that is 10 meters above. So that's going to be our initial height above the ground with an initial velocity of 5 meters per second. That's going to be our Vx. How far from the base of the cliff does it land? Okay, so since it's landing at the bottom, our HF is going to be 0. Okay, so here's all the things we know. We know HI is 10 meters. We know HF is 0 meters. We know our Vx is 5 meters per second. Excuse me. And we know our acceleration, or our g, is negative 9.8 meters per second squared. Okay, now, when you're doing a projectile problem, regardless of what they ask you, the first thing you need to do is you need to find your time. Okay? The first thing you do is you find time, regardless of what they ask you. Okay? They could ask you, what day of the week is it? It doesn't matter. You find time. Okay? What day of the week wouldn't make any sense. But anyway, so we want to find a formula that has, we also know our initial y velocity is 0 because it was a horizontal projectile. Forgot that. So we need to find a formula that has the h's in it. It can have a vi, y, it can have a g in it. It's not going to work. The vx equals d over t, that one won't work because we don't have d. So we need to find one that has h's in it, or a distance. Okay, so there's this formula. And figuring out which formula to use is really just trial and error. Like, the more problems you do, the more you'll figure it out, the easier it'll be to figure out which formula you need. Okay, so I get a lot of students asking me, like, well, how do I know which formula to use? You don't, you have to figure it out. And the best way to figure it out is to practice, practice, practice. Okay, so this is going to cross out. So we're going to have 0 equals 10 minus 4.9 t squared. I'm going to take this 10 and put it over here. I guess I could have taken the negative 4.9 to the other side. That would have gotten rid of the negatives as well. But oh well. I'm going to divide both sides by negative 4.9. That'll also get rid of the negative. Okay, so then I'm going to have, let me go over here. I'm going to have 2.04 equals t squared, not t squared. Take the square root, and then I'll get 1.42 seconds equals t. Okay, now that I have that t, now I can go ahead and I can find my how far from the base of the cliff. Okay, do not forget to do that part. I know I don't have a lot of space here, but we don't need a lot. So to get a how far, you're going to use Vx equals d over t. And now we have t, so we can use that. Okay. Your horizontal distance is always going to be found using this formula. So we're going to have d equals Vx times t, which is 5 is 1.42 which is equal to 7.14 meters. Okay, so that's the thing they actually wanted from me. Okay, don't get, oh my gosh, I'm so proud of myself, I found time, that you forget to find what they actually ask you for. Okay, next one. Okay, so now this is a circular motion problem. Okay, so we have a girl, she's spinning a yo-yo in a circle with a speed of 4 meters per second. So this is going to be our velocity. It says if the yo-yo has a centripetal acceleration of 6 meters per second squared, that's your AC. What is the length of the string? That's your radius. Okay, so we have B equals 4 meters per second. We have AC, and we put this little c here just to so we know that it's centripetal acceleration, and then we're going to find r. Okay, so our formula is AC equals v squared over r, and I'm looking for r, so I'm going to do AC is v squared over r, and this means that r is equal to v squared over AC, which is equal to 4 squared over 6, which is 16 over 6, which is 2.67 meters. That is our R. Okay. Again, this is just one of those formulas you just, it's not super difficult, but if you don't have this formula on your formula sheet, I can see where you might run into some troubles because you don't have the formula. Okay, so what does the term centripetal means? And it means to the center, or directed to the center. And this is because anything that's going in a circle, the acceleration is always going to be directed towards the center. Okay, so you might see to the center, you might see directed to the center, but it's basically to the center. Okay, so now our Newton's laws unit, we had a lot of formulas in the application of Newton's laws section, but we didn't actually have a ton of formulas in the Newton's laws test. Okay, that one was a lot of vocab. Okay, free body diagrams, stuff like that. Okay, so Newton's first law of motion says that an object in motion will remain in motion unless acted upon by an outside force. We need to write, I guess, in motion. No, that's supposed to be motion. Okay, this also means that an object at rest is going to remain at rest unless acted upon by an outside force as well. Okay, so for example, your car is going to keep driving unless you put the brakes on. Now, eventually it'll slow down, and that's because there's friction between the wheels and the tire, which is, there's friction as a force. But let's say you were driving on ice, which has, little to no friction, your car would remain in motion unless acted upon by your brakes or a tree or something. So here's friction. So friction can basically, it can be in any direction. It depends on the motion and the net force on the object. So usually friction, if you're going this way, your velocity is this way, your friction is usually in this direction. But it depends on your motion and also your net force. Okay, so you have to have both of those. So this one is just, this shouldn't be B or bolded like that. It's just that way. So it depends on the motion and the net force of the object. Okay, what way does the normal point in a free body diagram? So normal is always going to point perpendicular. Okay, if you have a flat surface, okay, your normal is going to point up like this, and that's going to be 90 degrees. If you have an angled surface, your normal is still going to be 90 degrees to that surface or perpendicular to that surface. Sorry, I shouldn't have drawn it. Bad physics. You should draw it always going away. Okay, so that's kind of how the normal is always going to be perpendicular to your surface. Okay. Okay, so what is the equation for the x-axis in this free body diagram? Okay, so our net force is going to be, and then basically our convention is that we're going to do this side minus this side. So we're going to have F minus F. Okay, and that should be 0. Okay, so that's kind of how that one will work. The next one. Okay, so in this one, we've got a free body diagram. Okay, this object has a mass of 8 kilograms, and it's accelerating at 2 meters per second downward. And then we need to know the value of the unknown force. That's the one right here. You can see it. So we're going to have a mass of 8 kilograms, an acceleration of 2 meters per second squared, -2 because it's downwards. And so now we need to write what we've got going on. Okay, so our net force is going to be whatever this force is minus 20. And F net is equal to MA. Excuse me. So our mass is 8. Our acceleration is -2. Our force, we don't know. And then we have 20. Okay, so this is going to be -16 equals F minus 20. We add 20 to this side. We're going to have 4 newtons will be that force. Okay, so that's how we find that one. Okay, so when a horse pulls a cart, see how the B is bolded in this one too. It's just how it is. It's not right. That doesn't mean that's the right answer. When a horse pulls a cart, we want to know what's going on in this. So which one of these is correct? It says the system accelerates because the horse pulls on the wagon. No. If you had like 0 friction or something like that, you know, your horse, it wouldn't accelerate. So we've got something else going on here that's not exactly what's happening. Okay, a horse and a wagon would not be considered a system. You can have whatever you want be a system. Okay, so it could be. And then it says the system cannot accelerate because the cart pulls back on the horse. Well, that's not possible, right? Because how else would a horse and a cart get anywhere, right? It has to be able to accelerate. And then it says the system accelerates because the horse pushes against the ground. Okay, so our system is our horse and our cart. Okay. And this system is going to accelerate because the horse is pushing against the ground, which is giving it that force. It's giving it what it needs to go forward. Okay, so this is going to be our correct answer. And the last one. What would be the reaction force if a man pushes on the ground to jump up and dunk a basketball? Okay, so let me see. Here's my man. He's pushing down on the ground so he can get up. And so the reaction force is going to be the opposite force to that. So somehow the ground has to push up on him. Okay, and that's how that's going to work. Okay, so the ground or the earth pushing up on the man is going to be your reaction force. Okay, so this is the last question I had for this unit for you guys. Um, again, make sure you look through those formulas. Excuse me. And you've got those with you. Um, you can see right here that we've just done this. Okay, so now we just have 2 more left, and we only have 2 more synchronous sessions total left too, which is kind of crazy. So make sure next week during Thanksgiving, if you are kind of on the edge in the class, try to, if you're traveling, maybe like write down the questions you missed, like something like that, or, you know, um, if you can download the YouTube videos of the synchronous session recordings, something so you can try and get ahead or use use that time to get those extra points for your test corrections and your synchronous session ELOs. Because if you think about a test, um, you can get a point back for the synchronous session ELO. You can get a point back for the final exam, and then you can get multiple points back for the test correction. So, um, you can raise your test grade pretty decently doing those, and then, going into the final exam, you're just going to, basically have yourself in the best position possible to get as good a grade as possible on in the course, because those things will help you prepare for the final exam, and then they'll also help kind of prepare your grade for the final exam as well. So, take advantage of those.